Hello everyone, my name is Kenji and I'm from the Intel group. Our group members consist of Neel, Arnav, Marcus, Teerthraj, Dhruv Awasthi, and under the leadership of our mentor, Dhruv Karia, over the past 3 weeks, we have created our AI project, the Fashion Detector. So, just as the name suggests, it is able to detect and find pieces of clothing, such as hoodies, jeans, and even glasses. So the reason why we chose this topic is because we wanted to do something that has not been done before. And so after looking through our previous projects, we landed on this concept of a fashion designer or detector because it stuck out as a unique and intriguing idea. Even though fashion and machine learning does not seem to have quite a direct relation, we found many practical uses for this tool. With 6 different classes, we're able to detect a variety of basic clothing articles that could be used for commercial purposes in finding trends among shoppers. In addition, with more training, we will also be able to detect a bit more specific clothing types that will help us identify people and even their distinctive qualities, which in addition will greatly benefit even investigative purposes in finding people and people who are sort of, yeah.
To source our images, we visited Google and Kaggle. Kaggle is a website full of data sets that contain quality images. And we went through a couple of the clothing data sets to find one that met our criteria. However, some had too many classes to label, while others had a limited selection. So the set chosen for hoodies was scraped from a store's webpage, and it was available on Kaggle. And the sets for glasses, hats, jeans, and pants were scraped from Google Images. We then filtered and processed the data as described in the next slide.
As for data preparation, to begin cleaning the data, we manually searched for any odd samples and removed them from our files. Most of these odd samples consisted of things like clip art images and super blurry images after taking images from Bing, and obviously that's not conducive to machine learning. Then with label box, we elaborated the boxes surrounding each object in each image for the ML algorithm to detect. And our classes consisted of hoodies, pants, glasses, jeans, hats, and shirts. After this, we put all of our information regarding bounding boxes into YOLO readable format to pass into the algorithm. One issue with fashion labeling in particular was that several photos had extruding sleeves or odd poses that caused the object in the image to be inaccurately represented. And this may have caused some distortion with the algorithm. After this, we separated the data into 3 bins, and for our purposes, we put 80% in training and 10% each into testing and validation.
In order to train our model, we formed our final weights by iterating through our 4,900 labeled training photos and adjusting the pre-trained weights. We then used our validation data to precisely tune our final weights so that the model was as accurate as possible. Finally, we formed a confusion matrix, which you can see on our slide, using our test data.
We had a few difficulties in creating our AI model. A few of them consisted of HTML and CSS troubleshooting, as a few of the elements on our webpage wasn't showing up. And some of the YOLO info files are missing class identifiers, so we had to fix that. We also had a lot of trouble with the intersection over union function and the confusion matrix function. And it was very tiring to gathering mass quantities of photos for all our classes.
I just want to say this doesn't sound like difficulties. This sounds like kinks along the way. I don't know. It sounds normal.
So yeah, there's a few things that we learned. Some of the most important things that we learned during the process of creating this is how to gather and process data using label box and just scraping web images and just being able to pull stuff from existing data frames, and also how to allocate tasks in the team, just how to break up the work and just make sure that we can all get a task done effectively. We learned the basics of Python, like lists and variables and for loops and conditional statements. And we also learned how to utilize libraries for streamlining purposes, how YOLO functions, and how to use and manipulate data with data frames and other data structures. We learned a lot about pandas and just data frames within pandas. And we also learned how CNNs and NNNs work and how computer vision works with them.
And so here's the link for our website. over here. So here's the fashion detector, where we can first find the homepage, and then in the overview, we describe the function of it, why we chose this project, and the uses for it. And the timeline, you can see in the first week, we learned about the basic Pythons, how to use label blocks to organize and gather data. In the second week, we learned more about the organization of this data using pandas and CSV files. We also were able to finish labeling our data. And so by the end of the week, we were able to successfully train the model. And in the third week, we mostly focused on building this website. Using Flask, we were able to embed the Python into the website where you can use it in the homepage. And we also use HTML and CSS to organize the website, which was quite an annoying process. And then lastly, you can see to meet the team with Arnav, Neel, Marcus, Teerthraj, Dhruv, me, and our mentor, Dhruv Karia. So let's try to use the thing where we can first put a test image. And as you can see, this person, we were able to find the hoodie and the glasses with 97 and 32% confidence respectively. And we can also find it with like one specific photo with, for example, specifically a hat. We're able to find it with 100% confidence. And in other ways you can do it is, if we take a look at an example of this pants, we're able to find it with 94 confidence. And with this, since it's a bit more structured, it will be able to find it within the bounding box without much of the pants being outside of it. And yeah, that's our project.